Hey Brand Bombers, it's Miss Morel, and we're going to kick off part 2 of section 5.1. So the nature of light. So sunlight contains a continuous range of wavelengths and frequencies, and a prism, so you think about like the triangle, a prism that breaks down sunlight, and so in that you can see all the colors of the rainbow. So the electromagnetic spectrum, it includes all forms of electromagnetic radiation. So here we can take a look at that. We have it all the way down to radio waves, all the way up to gamma waves, and we can see the visible light spectrum. All right, so the waves of the model of light cannot explain all of light's characteristics, like why heated objects emit only certain frequencies. And so there was a man named Max Planck, and he began searching for these explanations. And so Planck's constant is a word that we will hear a lot about. And so he came up with a formula to help us figure this out. So a quantum is the minimum amount of energy that can be gained or lost by an atom. And so Planck's constant, that is this number, the 6.63 times 10 to the negative 34th. So E represents the amount of energy, H is that Planck's constant, and V represents the frequency. So E equals HV, and H is that Planck's constant. So let's take a look at this. And here we do have a rounded number. We're going to round it to 6.63 times 10 to the negative 34. So let's take a look at this example. So we have 2.68 times 10 to the 6th. So E equals HV. And so we're looking for our E equals H. We know is that 6.63 times 10 to the negative 34. And we know that V is this number times 2.68 times 10 to the 6. So we're just going to simply multiply those numbers out. And voila, we are going to have our answer. So that comes out to 1.78 times 10 to the negative 27. If you are struggling to figure that out, make sure you can punch that into your calculator and get the right answer, okay? That's important. If you can't punch in your calculator, come see me, okay? All right. You have to erase all this so it doesn't stay on there. And going on to our next slide. So the photoelectric effect. So what does that mean? It is when electrons are emitted from a metal surface, they have a tendency to metal surface when a light of a certain frequency shines on it. So we can see that an electron is ejected. So we can see that things change. All right, so Albert Einstein proposed in 1905 that light has a dual nature. That means it can be particle and wavelength. So a photon is a particle of magnetic radiation with no mass that carries a quantum of energy. So this is that E equals HV. So let's go ahead and do some sample problems, you guys. Make sure you can do those to answer the daily questions. If you're struggling, come see me. What is the smallest amount of energy that it can be gained or lost by an atom? Do you know the answer? Hopefully. So that's called a quanta or a quantum. And one more question. What is a particle of electromagnetic radiation with no mass called? And so that is called a photon. All right, guys, if you made it to this far in the video, you are awesome. If you'll send me an email and say, Miss Morel, I made it to the end of the video, and you don't tell anyone. So if I get 100 emails and I only have 5 views on my video, no one's going to get points, okay? So make sure that you email me, tell me you made it to the end of the video, and I'll give you some extra credit points, guys. Thanks for being awesome. Take good care. Bye.